So, going to try to explain relative frequency in a simple way, or as simple as I can come up with. Not too, know what did I do that for, but anyway. Okay, so that's poorly done, but okay, it's good enough. Let's see. Let's say that I have 25 students in the room and I put a bowl of cookies out or something like that, bowl of Oreos, whatever. And I don't say anything. They can help themselves, etc. And then now the cookie bowl is empty. And let's say that there were, I don't know, I'm going to have to add because I didn't prep this beforehand. But let's say that I had X number of cookies. We'll count up how many I have after I throw the numbers down to make it easier for myself. So I noticed the cookies are done. I'm fine with it, but I figured, well, let's do a little math at the same time, kind of like I would do in the middle of class if we had class. And you'll soon discover that I have no class. Anyway, you're supposed to laugh at that. So I just query the students like, how many cookies did each of you have? And we do it by secret ballot, so if somebody doesn't feel like they ate too many or too few or didn't have any or something like that. So we all tear up a little scrap of paper and blah, 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 and throw it in a box. And I pull them out and I tally it all up. We have somebody or some number of students that took 0, 1, 2, and let's put 3. Okay? So 2 students ate 0. 5 students, let's say 7 students ate 1. And then 5 students ate 2. And 2 students ate 3 cookies. This is a frequency table. The data value or data point is 0, 1, 2, and 3. The 2, 7, 5, and 2 are the number of times that data occurs. Or in other words, if we plotted those points, let's do a dot plot. If we did a dot plot of this, it would look like this. We would have 2 dots at 0. We'd have 7 dots at 1. Barely put enough space. We'd have 5 dots at 2. And we'd have 2 dots at 3. Okay? That's a representation of our distribution. The majority of students took 1. A plurality of students took 1. The majority of students took 1 or 2, and then 3 of them took. 2 of them took 3. That was an error. Let's try to erase that. And then 2 of them took 0. So if I were to ask simple questions about this frequency table, I could ask, what is the mode? So remember, the mode is the most frequently occurring value. The most frequently occurring value, and that would be 1 because it occurred 7 times, right? You can see in the table, which is a little bit more difficult to see, but when I look at the dot plot, I can see that the values at 1, the number of times 1 occurs, stacks up to be 7 dots, which is the same as the frequency. So the mode is 1. That's the most frequently occurring value. It occurred 7 times. Don't confuse the 7. Okay? If I ask you what the median is, well, I know we're typically taught to list out all the numbers, so really if you did that, it'd be 0, 0, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 3, and 3. I would say that you don't really need to do that. You can. There's 5, and there's 1, 2, 3, 4, 5, 2, 2, and so our median is right between the 1 and the 1, which if I take the average or the mean of the 2 ones, I get 1. But you could also do this. There's 2, there's 2, here's 5 from that end, and then boop, there's those 2, here's our median. Okay? So, multiple ways to do it. You can just use the information that's in front of you. You could just use the frequency table if you wanted to. I'm just clearing this stuff off of here. So you might need the space and or the values. And so we get a median of 1. But you could have also done it this way. Here's 2, here's 2. If I lost 5, the least 5 ones, there aren't at least 5 ones, there's 7 of them. If I nix 5 of them here, there are 2 of them left. And so my median is going to be in there. Okay? In that row of the 7 ones. So my median is going to be 1. If I want to calculate the mean, I need to do the following. I need to count, I need to add up all the values. So remember I had 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2. I'd have to add all those up. An easier, faster way to do that is just to multiply. Come on, there we go. It's just to multiply extending the table. That's not what's happening in that example problem in the upper left-hand corner. That's not the same. But I can do the following. I could say 2 times 0 is 0. If I add the two zeros together, I'd have 0. 7 times 1 is 7. That's the sum of the 7 ones. 2 times 5 is 10. That's 2, 5 times. And then 2 times 3 is 6. And so that's the 2 3's added together. And so I get 23. Now, how many students did I have? Well, the number of students that ate cookies are in this column. So that's what? 4, 9, 16. So what is the mean? 23 divided by 16. And we get 23. Where's my slash? 16. I get 1.44 rounded, 1.44 cookies per student. Okay? On average, the students ate 1.44 cookies each. And so if I were to have an assembly of students that this subgroup of 16 students represents, then I could estimate the number of cookies I needed to purchase of 1.5, maybe to be conservative, 1.5 times the number of students, or even to be more conservative, I'll account for 2 cookies per student. And then because if I'm gathering 100 students in an auditorium or something, giving you free cookies, guess what? You're probably going to have to say, please limit your choice to 2, because some of them are going to want to take 3, 4, 5, and 6, although some will take 0. And then maybe when it's done, open the doors up for everybody else. Now, what is this table doing? This table is doing something a little bit different. It's trying to determine if you understand what's happening in a frequency table, but also understand what's happening in these 2 additional columns. So I will explain those ideas with this exact same table with the cookies. I'm going to add a column to try to represent what's going on here. Not a column, I'm going to add a row. I'm going to add another data point of 4. And I'm going to play the game like they're playing in this problem. I don't know if I'm going to get all those. Okay. So let's say that I have a blank there. But here's the thing, that problem tells you that they talk to 90 adults. Let's say that I didn't have 16 students, I had 20 students in the room. Okay? And when I tallied up the pieces of paper, I had 2 students told me 0, 7 students told me 1, 5 students told me 2, and 2 students told me 3. I counted up and say, well, like, what the heck? 4 of you didn't respond. They were probably felt guilty that they ate 4 cookies apiece or something. I don't know. But I know that there are 20 students in the room. I know that there are 16 responses. That's what we added up before, right? Double checking 9, 16. So I know that this has to be a 4. Okay? Because this has to add up to 20. That's what this column is asking for, or excuse me, this little box right here, that's what it's asking for. It's asking for the missing number. So you have to add up all those numbers, subtract that sum from 90 to figure out how many of these people only flossed once a week or whatever it is. Okay? Whatever the scenario is. All right, now that we have that, what is relative frequency? Well, relative frequency is just like frequency, except it's relative to the population. So it really is a percentage that value occurs. So in other words, this 2 occurs what percentage out of the 20? So that's 10%, right? 2 divided by 20 is 10%. Just like, for instance, 13 out of 90, 13 divided by 90 is 1.44%. That's this. That's 13.144. And you're saying, well, that's the wrong row, dummy. Yes, but no. I know that this answer is 13. Why? because the cumulative frequency, but also if I add up those numbers, subtract them from 90, you'll figure out that this box, this empty cell, is 13. 13 is what percentage of the total of 90? So 13 divided by 90 gives me that percentage. The same 13, a different 13, but the same value, divided by 90 again gives me 0.144. 6 divided by 90 will give me that 0.0667. Like that. These are all the relative frequencies. So in other words, we can look at the 16 and say, yep, that's the most frequently occurring value. We could also look at this percentage, 0.177, and note that it's the highest. It's actually not a percentage, it's a decimal. And that 0.177, or approximately 18%, is the most frequently occurring, or the highest percentage, which also indicates that that 7 is the most frequently occurring value. Okay? So relative frequency is just a percentage. So if we did that for our little table here, 7 divided by 20 is going to be under a half, of course. But how far? My keyboard's all cockeyed here. It's all wacky. And 5 divided by 20 is 25%. And then 2 divided by 20 we already determined is 10%. And 4 divided by 20 is 20%, because it's double that, 40. This column always has to add up to 1, because 1 would be 100%. So those decimals all have to add up to 1. So we can double check this. 5 and 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. What is cumulative frequency? Well, cumulative frequency is just what is the frequency of this value, or the frequency of this data or value, plus all the ones less than it. So that's why the first one would be 2, cumulative frequency. And if I add the 7, that'll be 9, meaning there are 9 values that are 1 or less. There are 14 values that are 2 or less. There are 16 values that are 2 or less. There are 20 values that are, 3 or less, and 20 values that are 4 or less. That's why this one, this last one, is going to be 90. Notice how 74 plus the 16 is in fact 90. Okay? So that's that table. And our extension to represent that same idea, those same ideas. Complete the table using 4 decimal places when applicable. So that we could do, you could do. What is the cumulative relative frequency for flossing 4 times per week? So that is 52. All right. So hopefully this clears some things up for some folks.